how our politicians behave, whether our governments represent us, and whether we can hold them to account if they let us down.
So guys, there are 6 common methods of voting system.
First is the plurality method. Each voter votes for one candidate. The candidate with the most first place votes is the winner. Example, the math club conducted an election and the results were as shown in. Since plurality counts only first place votes, we can see that A got 7 votes in column 1 with 7 at the top. S got 5 votes in column 2 and P got 4 plus 2 minus 6 votes. Mushroom was never get at the top, so it got no votes. The question is, did any of the rankings get the majority of the votes? None of the rankings that got a majority of the votes, since there are 5 plus 4 plus 2 plus 7 equals 18 voters. More than 18.5 equals 9 voters are needed for a majority.
Number 2. Plurality with runoff method. Each voter votes for one candidate. If a candidate receives a majority of votes, that candidate is the winner. If no candidate receives a majority, eliminate all but the 2 top candidates and hold a runoff election. The candidate that receives a majority in the runoff election is the winner. Example. Refer to the data in number 1. Find the winner using plurality with runoff. So guys, since the top 2 votes getters were A and P, all others are eliminated, and we are run an election between A and P. Look at the table and mentally, or you can actually do it with a pencil. Cross out all the S and M entries. Now look at the first column. There are 7 people who prefer A to P. The second, third, and fourth column have 5 plus 4 plus 2 plus 11 people who prefer P to A. Note that in this column we are only concerned with the fact that P is preferred to A, not the particular value of the preferences. 11 is the majority of the 7 plus 5 plus 4 plus 2 with minus 18 people voting in the election. Those A and 7 votes against P as 11, and P is the new winner using the plurality with runoff method. Number 3. The Borda count method. Voters rank candidate from most to least favorable. Each last place vote is awarded no point. Each next to last place vote is awarded 1 point. Each third from last place vote is awarded 2 points, and so on. The candidate who receives the most points is the winner. Example. Find the winner of the election in example 1 using the Borda count method. So guys, award 0, 1, 2, and 3 points to the last, next to last, and so on. Counting the points for anchovies, A in column 1 of the table, you get 7 first place votes, worth 3 points each. A total of 3 times 7 minus 21 points. Sausage S gets 2 times 7 in column 1, 3 times 5 in column 2, 2 times 4 in column 3, and 1 times 2 in column 4, for a total of 14 plus 15 plus 18 plus 2 equals 39 points. Pepperoni gets 10 points in column 2, 12 in 3, and 6 in 4 for a total of 28 points. Finally, mushroom gets 7 points in column 1, 5 in 2, 4 in 3, and 4 in 4 for a total of 20 points. Those using a Borda count method, the rankings are winner S, winner P, A, and M with 39, 28, 21, and 20 points respectively. Number 4. Plurality with elimination method, the hair method. Each voter votes for one candidate. If a candidate receives a majority of votes, that candidate is the winner. If no candidate receives a majority, eliminate the candidates with the fewest votes and hold another election. If there is a tie for fewest votes, eliminate all candidates tied for fewest votes. Repeat this process until a candidate receives a majority. Example of using plurality with elimination method. Consider the familiar pizza voting. Which topping wins the election using the plurality with elimination method. So guys, A has 7 votes in first column, S has 5 votes in second column, P has 4 plus 2 equals 6 votes at third and fourth columns, M has no vote. Since there are 5 plus 7 plus 4 plus 2, 8 equals 18 voters, we need 10 more votes for a majority. None of the toppings has a majority of the votes, but M receives a fewest first place votes. So M is eliminated, and all sections in each column between M move up 1 as shown in the table 2. Now as A has still 7, S has 5, and P has 4, plus 2 equals 6. Since S has the fewest votes, S is eliminated, and we are down to just P and A. As shown in table 3, now P is the clear majority winner with 5 plus 6 equals 11 votes. Thus P is the winner of the election when we use the plurality with elimination method.
Number 4. Pairwise comparison method. Voters the candidates from most to less favorite. Each candidate is then compared with each of the other candidates. If candidate A is preferred to candidate B, then A receives of 1 point. If candidate B is preferred to candidate. Example number 4. The results of elections involving the candidates A, B, and C are shown in a table who wins the elections using the pairwise comparison method. The number 2, ABC, 3, BCA, 4, CAB. Solution number 4. To determine the winner using the pairwise comparison method, we have to compare A and B, A and C, and B and C. Suppose the elections is between just A and B, leave C out. A, 2 votes from column 1 and 4 from column 3, a total of B, 3 votes from column 2, a total of 3 votes. Those beats B, 6 votes to 3, and A is awarded 1 point. Now let us compare A and C, leave B out. A, 2 votes from column 1, a total of 2 votes. C, 3 votes column 2 and 4 votes from 3, a total of 7 votes. Thus C beats A 7 votes 2, and C is awarded 1 point finally. Let us compare B and C, leave A out. 2 votes from column 1 and 3 from columns 2, a total of 5 votes. C, 4 votes from column 3, a total of 4 votes. B beats C as votes 2, 4, and B is awarded 1 point. What a dilemma. All the candidates have 1 point. There is no Condorcet winner in this election. A Condorcet candidate is one who beats all other is head-to-head comparison. Number 5. Approval voting. Approval. Voting uses a determined kind of preference table. The good news is that the table is much simpler in one respect. Each voter does not have a rank all the candidates first, second, and third, and so on. Instead, each voter simply approves A or disapproves D, each candidate. Thus, if you are a voter, you can vote for one candidate, 2 candidates, 3 candidates, and so on. Voting 2 or more candidates doesn't dilute your vote. Each candidate that you are approved of gets 1 full vote. When the votes are counted, the candidate with the most approval votes win. Number 5 example. In the given table, each row corresponds to a different candidates W, X, Y, and 2, and each column corresponds to a different voter. An A means approve and AD means disapprove. Which of the candidates wins using approval voting? Candidate W, X, Y, Z. Voter 1 AADD. Voter 2 BADD. Voter 3 ADAA. Voter 4, ADDD. Voter 5, DADA. Voter 6, DDAA. Voter 7, DAAD. Voter 8, DAAA. Number 5 solution. We examine each of the rows and count only the AS. Row W has 3 AS. Row X has 5 AS. Row Y has 4 AS. Row 2 has 4 AS. This means the candidate 2 wins with the 5 votes. Y and Z are tied with 4 votes each, and W is in last place with only 3 votes.
There are 4 methods of apportionment. But before we go on of these methods of apportionment also can be called methods in determining apportionment. We have here given 2 formulas that we should use in methods of apportionment. The first is standard divisor, and the second is the standard quota. The first formula is the formula if we find the standard divisor. This is the ratio of the total population of the number of seats. It tells us how many people are represented by each seat. The formula of the standard divisor is the total population in the group should be divided to the total number to be apportioned. The second formula that was given is the formula if we find the standard quota. According to the quota condition, an apportionment method is considered fair if the difference between the ideal share and the realized number of the seats remains within narrow bounds. For the formula of this standard quota, the population in the group should be divided into the standard divisor. Now, as I have said earlier, we have 4 methods of apportionment. The first method is the Alexander Hamilton's method. The second is the Jefferson's method, followed by the Webster method, then Adams method. For Hamilton's method, it was introduced by the Treasury Secretary Alexander Hamilton in 1791. Hamilton's method is the earliest method of apportionment. So, this method is the first method that was released. It determines if how many people each representative should present. To determine if how many representatives that we should have, we should divide first each state by population by the divisor. Then record the answer to several decimal places. To find the divisor, you should divide the total population by the total number of representatives. In this method, it sets the divisor as a proportion for the total population per house seat. After each state's population is divided by the divisor, the whole number of the quotient is kept and the fraction dropped. And this will result in surplus house seats. So, if you are asking about the integer of this Hamilton's method, the integer of this is down to the nearest integer. It distributes leftover items to the groups with the largest fractional part until all the items are distributed.
This is an example of Hamilton's method.
The next method that we have is the Jefferson's method. It was developed by the future President Thomas Jefferson and enforced for the allocation of seats in the House of Representatives after President George Washington's veto of the Hamilton's method. This method remained the apportionment method until 1842 and is still used in countries such as Japan, Slovenia, the Netherlands, and Israel. The Jefferson's method avoid the problem of an apportionment, resulting in a surplus of a deficit of house seats by using a divisor that will result in the correct number of seats being apportioned. This method helps to determine how many people each representative should present. To determine this, you should perform the standard divisor formula. And as for the process of this method, it is the same as we perform the Hamilton's method in finding the standard divisor and standard quota. Thomas Jefferson proposed a different method for apportionment. After Washington vetoed Hamilton's method, Jefferson's method was adopted and used in Congress from 1791 through 1842. The modified divisor is less than the standard divisor. In the integer 1842 and 1852, and also between 1911 and 1941. The other countries using Webster method are Bosnia, Norway, and even Germany since 2009. The Webster method also violates the quota condition. However, it favors big parties less than the Jefferson methods does. This method is a modified version of a Hamilton's method. After the state population are divided by the divisor, those with quotients that have fraction of 0.5 or above are awarded as an extra seat. Note of that, the fraction have 0.5 or above are awarded as an extra seat. In the states with a quotient with a fraction below 0.5, have the fraction drop. If you have a fraction 0.5 below, the fraction drop. The process of this method was same as Hamilton's method. In Webster method of apportionment, it is one such method proposed and adopted by the House. It states that apportioning should be accomplished through the selection of a divisor such that the ultimate traditionally rounded quotas will sum to the exact number of seats to be assigned. So the modified divisor of this method is lesser than, greater than, or equal to the standard divisor. It is to the nearest integer. So the integer of this method is in the nearest. The apportion to each group is a modified rounded quota. So the last method that we have, as I have said earlier, is the Adams method. This method was suggested in 1822 by the former President John Quincy Adams, but this method was never been used. This method was never been used and not used at all, like all divisor methods. The Adams method violates the quota condition. Of all the methods discussed, this method is mostly favors small parties or states, which again may be one reason why it is so rarely used. Adams methods divides all populations by a modified divisor and then rounds the results up to the upper quota. Just like Jefferson's method, we keep guessing modified divisors until the method assigns